Hello everybody, thank you for joining me today. I'm going to present you the newest features in Microgateway 4.6. My name is Stefan Dietiker and I'm the product manager of Airlock Microgateway. I have a few topics that I want to cover. First, the main new feature of Microgateway 4.6, some miscellaneous features and changes. The new version, Microgateway 4.6, comes with a bunch of new features and improvements. The main new feature is JWT Authentication, and we provide you great improvements for OIDC, Relying Party, and Grafana Dashboards. Microgateway 4.6 introduces a powerful new feature, JWT-based client authentication. With this update, Microgateway verifies the validity and signature of JWTs sent along with client requests. This ensures that customers can rely on Airlock's robust security to correctly authenticate JWTs. Additionally, Microgateway 4.6 supports fine-grained access control policies based on JWT claims to either grant or deny access of certain HTTP requests. For protected web applications that do not natively support JWT, Microgateway can extract information from JWT claims for identity propagation, enabling seamless integration. For example, a simple header containing the username can be sent to the protected web application. The following slides help to illustrate the authentication steps. The example shows how a user tries to access a web application protected by Airlock Microgateway. The client sends an HTTP request with a JWT to access a certain resource. Airlock Microgateway fetches the JWKS from a remote endpoint to verify the JWT signature. After that, the access control policies are evaluated. If access is granted, the request is forwarded to the web application, either with the original JWT or a header containing user's name via an identity propagation feature. Microgateway 4.6 now supports the OAuth 2 standard, token exchange, which can be used with JWT or OIDC. This new capability allows to exchange security tokens from an external security zone to internal tokens. This ensures that security tokens are only valid within a certain security zone. Policies at the zone boundary enforce which tokens are permitted in the other security zone. The subsequent slides will illustrate this concept further. The following slide illustrates the steps for an OIDC-aware device to access a front-end REST service in the front-end security zone. In the first step, the OIDC-aware device authenticates against a user IDP and finally receives a blue access token from the OIDC provider. Next, the device sends an HTTP request with the blue token to access the front-end REST service. Airlock Microgateway verifies the validity and signature of the blue token sent along with the client request. After that, the access control policies are checked. If access is granted, the blue token is forwarded to the token exchange server, which exchanges the blue token into a red token. Finally, Microgateway forwards the request with the red token to the front-end REST service. The following slide illustrates the steps for an OIDC unaware web application to access a front-end REST service in the front-end security zone. Since the web application is unaware of OIDC, Microgateway has the role of the OIDC relying party. In the first step, the browser sends a request to Microgateway. Since the user is unauthenticated, Microgateway redirects the user to the user IDP. The user authenticates against the user IDP. After successful authentication, the user is redirected back to Microgateway with an access code. Microgateway requests the blue access token from the user IDP, verifies the validity and signature of it, and checks if the access control policies are valid. If access is granted, the blue token is forwarded to the token exchange server, which exchanges the blue token into a red token. Finally, Microgateway forwards the request with the red token to the front-end REST service. The following slide illustrates the steps for an OIDC-aware device to access a front-end REST service in the front-end security zone, which then accesses a back-end REST service. Both REST services are protected by Airlock Microgateway. In the first step, the OIDC-aware device authenticates against a user IDP and finally receives a blue access token from the OIDC provider. Next, the device sends an HTTP request with the blue token to access the front-end REST service. The Airlock Microgateway in the red security zone verifies the validity and signature of the blue token sent along with the client request. After that, the access control policies are checked. If access is granted, the blue token is forwarded to the token exchange server, which exchanges the blue token into a red token. Afterwards, the Microgateway in the red security zone forwards the request with the red token to the front-end REST service. The front-end REST service forwards the request with the red token to the back-end REST service in the green security zone. The Microgateway in the green security zone verifies the validity and signature of the red token sent along with the client request. After that, the access control policies are checked. If access is granted, the red token is forwarded to the token exchange server, which exchanges the red token into a green token. Finally, the Microgateway in the green security zone forwards the request with the green token to the backend REST service. Supporting the OAuth 2 standard token exchange offers numerous benefits for customers. I'd like to highlight some of them. With the architecture presented in the previous slide, access to restricted resources is only possible for authenticated and authorized users, and only from trusted identity providers. The setup with Microgateway simplifies management and monitoring by processing all authentication requests centrally. Microgateway supports OIDC and JWT out of the box. This already brings great flexibility. With token exchange, even more authentication mechanisms can be used. Thanks to standard protocols, customers benefit from great interoperability across systems. There are many reasons why different security zones come in place. A desired reason could be to restrict what can be done with a certain token. The token is restricted to a security zone and cannot be used elsewhere. An undesired reason could be that services of a supply chain is running by different companies or sub-supplier. Each of them have their own identities, and it is not easy to bridge them. As an example, public SaaS services on Azure are using Entra IDs but need to access internal resources. These internal resources are unaware of Entra ID, and modifying them costs a lot and brings great project risk to the table. Therefore, Microgateway enables seamless supply chain digitalization. Leveraging the feature token exchange could be beneficial from a licensing perspective. This way, not all users need an account in the external identity provider like Entra ID. By doing that, potentially license costs could be reduced. With Microgateway, authentication becomes an infrastructure part. This means it is a toolbox customers can rely on, which is securely developed and maintained. This results in a faster time to market for new web applications and APIs. By reducing the validity of a token to a security zone, the risk of token theft and misuse could be reduced tremendously. This way, only trusted and verified tokens can be used in a specific security zone. Finally, the conversion is handled transparently, which facilitates integration. The protected web application does not need to know that token exchange was in place. Microgateway 4.6 comes with improved Grafana Dashboards. The new dashboard with system metrics provides valuable insights about CPU and memory consumption of the Microgateway engine container and displays pod network traffic for better resource monitoring. Besides that, the container status of the engine container is shown. Another new dashboard visualizes HTTP request key metrics, including the number of requests, status codes, and bytes sent and received. This offers important operational insights such as the number of handled HTTP requests and success rates of the HTTP status codes. The following screenshot gives an idea of the Grafana dashboards provided by Argon. We see the engine container readiness of a selected pod, the requested and limited CPU and memory usage. At the bottom, we see the network traffic sent and received by this pod. I'd like to say thank you for your time and hope that you enjoy the new Microgateway release. Goodbye.